over the centuries, water wheels developed from being just a paddly thing that fitted into, dipped into a river, to being an overshot wheel, which actually used gravity and the energy that could be imparted by the use of gravity to become an overshot water wheel. We're at the Silk Museum in Derby, and behind me is the inlet fan of a giant jet engine from 70s through to sort of 90s passenger aircraft. Loosely speaking, this would be a turbine, although they don't actually call it a turbine in the form of jet engines, because they refer to the pressurised components inside the engine as turbines. But basically, this is using fluid being pushed through to make a radial force happen, tangential to the flow of the fluid. And this could apply to any fluid. It could be water, it could be air, it could be any kind of gas or liquid. At the front of the engine, basically starts to compress the air into the combustion chamber of the jet engine, and it goes to up to about 40 times normal atmospheric pressure by the time it's in the middle of the engine, and then it starts to burn, so it gets even more compressed and gets shot out the back and makes this enormous thrust that actually makes hundreds of tons of aircraft go up into the sky, which is something that's always amazing me, really. It just shouldn't work, all those big heavy things. Part of the engine that we were looking at previously was the inlet fan. Now on this engine it's a different kind of inlet fan because it sucks it in sideways rather than straight in at the front. But then when the actual parts that they refer to normally as turbines in jet engines are the actual parts in and after the combustion chamber, where the air or the fluid, by which point it'll have the fuel in it as well, is at absolute maximum temperature and pressure.
Okay, so here we are at Massey Mills in Cromford, and they actually generate their electricity using turbines. They normally use a more modern turbine. This is their old turbine that they're running specially, and as you can see, it's quite a noisy piece of equipment. Since they've turned it on in the last 2 minutes or so, the water level in the mill stream's dropped by about a foot, so it uses quite a lot of water, but it's very efficient in its taking the power from the flow of fluid and turning it into another energy form, which in this case is this rotational shaft behind me, which goes and drives the generator in the main building. Rotational energy from the drive shaft, from the turbine outside, is transmitted through that green box behind me into this generator set next to me, and then next to that there's a modern looking metal cabinet which apparently phases the electricity so that it can be in synchronisation with the national grid, so that the energy that water's generating in the River Derwent now is actually being fed into people's homes around the country. The problem with the turbine, well, I've not encountered a problem. They're having real trouble trying to make it stop. It's such an efficient device that it just wants to keep going. There's such a weight of water on the turbine blades that despite the fact there's a bizarre and very fantastic sort of looking stick thing that they use as a brake, and that they've tried to hydraulically shut down the buckets in the turbine so that it will stop, it's really trying to keep going. But this looks like they're winning. Energy from the line shaft is transferred onto each individual machine, such as this Mule, which converts the roving, which is kind of a soft stringy stuff, into cotton twine by means of further flat drive belts, which sometimes have twists in. As this machine comes forwards, it stretches the rovings off the rolls on the back onto the little wheels of, it stretches it out and twists it as it comes out, and then as it goes back in, it winds it onto the spools. And it was this kind of repeat imagery of the lines of rovings and the spools of yarn that made me think of doing things with those conical cardboard bobbins with all the repeat images with all the school kids and that, which is how the Balpa sculpture came about. This machine was one of the machines that really inspired, one of the machines that early on really inspired me about the mechanisms in the machinery in the mills. And this one I think they call it a doubling machine or something, because it twists several colours of yarn together to make kind of a stringy type thing. But what I really liked was all these bobbins, normally when it's in full production these will all be going round, spin round, and as they spin round they go up and down. They all go up and down at once at the same time. And as they go up and down, the cotton is threaded in at the same point all the time. And so they have has the effect of weaving it, of rolling it around the bobbins in a uniform fashion. And I suppose if you control the movement up and down, you can make all sorts of shapes. You can make like three-dimensional Arkwrightian shapes, like a head with a funny bumpy hairstyle and then a big round belly, and then sort of a more bulbous kind of legs. Just by controlling the speed, the whole thing goes up and down, because I think normally it just goes fairly constant. With this doubling machine, in this particular line, these three colours of cotton thread are being drawn in by the bobbin as it spins round, and as they go, once they get past this roller, the circular motion of the reel twines them together so they make like a spiral, and then as they go round the cotton reel, or the bobbin rather, at the bottom, it winds them onto itself, and because it's going up and down, it does make that uniform thickness all the way up and down.
Here we are at Balpa North Mill, where Jedediah Strutt, who this isn't, invented a machine which automated the production of stockings using a process known as Derby rib, which enabled the cotton to be made into an elasticated type material, which meant that your socks stayed up. And initially, all the machines just made this flat, straight section of cotton, which had to be stitched up to form the stockings. Modern socks, such as this example here, don't regularly have seams up the side, and this has been made possible by the invention of a circular weaving machine, which in this case you can see is fed by these conical cotton bobbins, which are identical to the ones that I used in all the school and community workshops to make the ceramic little figures that sit behind and on the rotating parts of the sculpture I've made for the North Mill. And when it goes round, you can see the beautiful movement of the mechanism. It's almost like a wave going around in a circular fashion, and this just goes on, well, as long as the cotton lasts, to make indefinitely long socks. You could make the longest sock in the world. I suppose you could join the thread and make it infinitely long. A sock that goes to the moon. This also links in with, this is the same weave that Tan uses in his circular weaving workshop for the big woven cloth pieces that he makes.